Okay, so now we're gonna do problem 4 of Project Euler. I made my screen a little bigger so that it's easier to see, and I'll do the same here. Okay, so palindromic number reads the same both ways. The largest palindrome made from the product of two-digit numbers is 9009 equals 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. Okay. So I'm already thinking we might need to do a situation where we're changing these numbers into strings. That might not be the right way, but that's what I'm thinking right now. If we're doing two three-digit numbers, then we know that the output will be a six-digit number, right? So I know that, and let me write this down as notes. So we know that a number with three digits will equal a new number with six digits. Okay. So we need to find out what that number is from the product of two three-digit numbers. And this has to be a palindrome, right? So the digits must be the same. So let's do like A, B, B, C, C, okay? That's what we want. I don't know, let's do N. Okay, in the example they gave us, we have 9009 equals 91. 9009, let me do it the opposite way. 91 times 99, or 90, it was 99, equals 9009. Okay. So let's see. How can we go about this? I mean, that will be, so I guess it'll be towards the, obviously it'll be towards the top, right? So it might be like 9, 5 something, or 999. I don't know, because obviously we want to maximize the values. And I guess in this instance, right, if we do just one more, it would go over. And this is the highest number we can possibly go within a two-digit limitation. So, I mean, just thinking about that approach, it's like, okay, well, what if one of them is 999, and then multiply that by, I don't even know, however many digits, right? So like 2 to get it up to here, and then so on and so on. But the point being, maybe it's a number with 999 by something. Or maybe not. Or maybe a better combination would be 98, or not in this case, but 998 times a different number, right? Because it's able to go higher. I don't know. This is gonna be a tricky one. But we know that the value has to be a palindrome. That's what we know, and that's what we're starting off with. Now, another thing I'm noticing, 9 and 9, and then these two kind of cancel out, so it's like a 0 potentially. I don't know. Yeah, so I guess, I don't know. It could be so many things. How can we go about this? So what's the largest palindrome made? I mean, we can try to think about it for the two, right? How will we find out that this is the largest palindrome? From 2 digits. I guess one thing we could do, right? One thing we could do, we can literally have a loop where we start at 9 multiplied by 9. I know that's not right. In reality, it's going to be some other number, but if we start there, we check if it is 6-digit and a palindrome. Okay. And then if not, then we decrease the value of one of the numbers. Or I guess in this case, or just check, we just check all combos. Or just check all combos. And log the highest value. Okay. That's not bad at all, actually. So let's say, and let's do it for the example we know. We're going to put in the digits. Okay. So we're going to input the digits, and then we'll use that as like our gauge, right? So first thing, we're gonna have to log what the current highest is. So let's just have a variable called highest equals 0. And then we're going to eventually return this variable because it'll get overwritten. So now, two, 3 digits. So maybe instead of, we do, or digits is like this, like how many of these factor, or how many digits the factor has. That might be a little cleaner. So, okay, let me think about this. For here, we need to, it's 2 digits, right? For n in digits, we want to, actually we're going to do a equals 9. Oh, just do an empty string. A equals that, B equals that. Okay. So then what we're going to do is for n in digits, so however many values there are in digits, in the case 2, we will add a 9 to each digit. So it'll be a dot append, or actually we can just do that because Python is sweet. It's sweet like that. Is it plus equals or equals plus? Oh, let's look this up real quick. Yeah, okay, you can. And it's plus equals. Sweet. All right, so a plus equals that, and then b plus equals that. Okay, perfect. So now what we're gonna do is for n, and I guess we didn't have to do for n. Oh well. For, what's the better way to do this? It's definitely a better way to do this, but I don't know. All right, we're gonna ask the AI once more, just to be sure. Don't mind that, that's just some editing stuff. How can I write a loop without a variable in Python? There's a typo. Okay. Oh, enumerate. I remember enumerate. That's if we need the index. Okay, cool. So I'm doing it right. I put it back, but yeah, sweet. Okay. Okay, so then after we do that, what we want to do is we want to multiply those two numbers. So we're going to have to turn them into integers. And then we're going to want to see. Okay, and also we got to think about this too. So it's a little tricky, but we want to do this for as many values as there are in for both A and B. So it'll be for A dot I in A. So we want to do it this way. What if we don't care about this? I guess we'll stop it at 1. There we go. Okay. So basically what we're saying is, and also we gotta +1 here because it doesn't start, it's not inclusive. So starting at the highest digit, so 999 or 99, we're going to go all the way down to 1, and we're gonna do that taking -1 steps. And then this value will be represented by AI, A underscore I. Okay, cool. And then we're going to do the same exact thing. So let me just copy paste this. Do the same exact thing, but instead of A, we're going to do B. Okay. This is the idea. Oops. Okay. So now we have the number AI and BI. So we're going to palindrome. What should I call this variable? Multiple equals A underscore I multiply B underscore I. Okay. So now we have the multiple, so now it's like, okay, what do we... We're going to have to check two things. We're going to have to check if this multiple is the right amount of digits. Or I guess we don't have to, right? It didn't specify. I'm fixating on that too much. Most importantly, we just have to check if this multiple is a palindrome, right? So we're going to take... and honestly, we could just do this too. str. There we go. And then we have to check. Oh, how do you check if a thing is a palindrome? Let's do a helper function here. Is palindrome multiple? Okay. I'm gonna do this guy up here. I'll do this guy down here. Def is palindrome num. Oops. I'm gonna make sure this is a string as well. Oh wait, do I have to write it out? Capital. I'm not sure how to do a strict type. I forgot how to do that. That's okay though. We could do that later. So now we have to check if this is a palindrome, and then if it is, then we set the highest. Well, I guess we don't have to set the highest, right? Because we're going downwards, we don't need to go through the whole list, right? Since the whole list is just, the rest of this is going to be lower. I mean, I don't know. Let me think. I have to think about this. Is that possible? Is it possible that this would not be? I don't know. I want to say it is possible that 998, but then again, we're going to see those anyways in the first round, right? Because there's no way there's a situation where two numbers of lower values, well, there's like, I don't know. We're going to play it safe, but that's something I'm going to have to think about. And besides, I have the infrastructure here anyways. So we're going to set the highest equal to this multiple if it is a palindrome. But we want to get the max of whatever this multiple is and whatever the current highest is. Because there might be a situation where it is a palindrome, but it's not as big as our current palindrome that we have, and bada ba bing, bada boom, you know? Cool. So, does this part make sense? Let's just double check. We get the amount of digits we need, and then for A, starting at the very top, going downwards to 1, bum. And then the same thing for B. And then we multiply those two, we get a number, and we turn that into a string. And then we take the string, we pass it into is palindrome, check if it is. And if it is, we compare it to our current highest. And then we do this, and then when this loop is finished, we return the highest. Now, how do we check if something is a palindrome? If it is an even number of, and that's another thing, But because we know that I guess that's not always true, huh? I was going to say, because we know it's 3 by 3 digits, it'll be 6, but that's not true. Now that I think about it, a counterexample would be 2 times 2. That's 4. It's still 1 digit. So, yeah. So we can't assume. So we have to figure out if it's even or odd. So we can start with that. So if length of num mod 2 equals 0, then we will do stuff. Else do this. False. Oh, well, I guess we're going to need a true or false. So we'll do a result. So we'll say result equals none. And then, okay, blah, blah, blah. We're not going to return anything. We will eventually return result, though. Okay. Do stuff. Cool. So what we want to do, we're going to obviously have a scenario where one result equals true, and then another scenario where another result equals false. Right? And that'll be true for both conditions here. Okay, blah, 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 blah. And the way we can check if it is true or not is if in the case that it's even, we will check that it's a palindrome. So we'll break it into 2 pieces. So let's do 1, 2, 3, 3, 2, 1. We'll break it into 2 pieces. So 1, 2, 3, 3, 2, 1. And then we'll flip the second piece so that it's that we're comparing the last digit to the first of the first set. And then in the case where it's not even, we're going to discard the center and then do what's above. Okay. I think that's an okay way to do about it. So what we can do, so let's do the even first. So if it's even, we're going to break it into 2 pieces. So we're going to say second half. Let me think. Tail equals num from, and let me, just for my sanity. Oh. Halfway equals len of num divided by 2. So then the tail will be from halfway to the end. Okay? And then, So theoretically, we'll have the tail like there appropriately. So what we can do is check if, well, yeah, well, 1 second. We want this backwards, so like that. Yeah, so it'll start at this index, end at the end, and we're gonna do it backwards. And this is the tail. And I guess we could describe the head explicitly. It would be easier that way, wouldn't it? So we can say that the head is, we could say that it's this, but not backwards, because we don't want to flip it backwards. Instead of that, we'll go halfway. So now let me verify that this makes sense. So what we're telling it to do is look at the length of this, 6, and then we know that half of that's 3. So then starting at index 3, so 0, 1, 2, 3, we're going to take this piece, reverse it. Okay, perfect. So we actually don't want halfway in this case. In this case, we'd want halfway minus 1, which is tricky because that might not always be allowed, right? So in this case, it would work. 1, 2, 3, 3, 2, 1. Halfway minus 1 is 2, so 0, 1, 2. So it'll be that guy. Versus like, well, I guess this is odd, but if it's like 2 digits, how would that work? Halfway of this is 2, 0, 1, that works. If it's 1 digit, it does not work, which is okay. I'm okay with that. So we'll do that. Oh, no, not there. There we go. Cool. So now, if head equal tail, result equals true. It is. Else, no bueno. Okay, cool. And that makes sense. And that should work. Maybe not when they're both 1 digits, but that's okay. We don't care. Won't work for 1 by 1 digits. Well, that's okay though. Okay, so this makes sense. So otherwise, when it's an odd number, we can't just divide it by half. We have to find that middle digit, right? So in this case, where it's 5 digits, 5 divided by 2 is 2.5. We round it up to 3. And is that the right position? No. 0, 1, 2. In this case, it's a 2 position, so we have to go down. But what if it's, I don't know, 1, 2, 3, 4, 5. Okay. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits. So that's 4.5. So it'll be 0, 1, 2, 3, 4. Yeah, so we do want to do the floor. Okay. So we can do that. So same idea. Well, let's start here. Halfway. And then, but that's the tricky thing, right? We want to knock it out. How do we, is there a way to remove the index? Is that the approach we want to do? I mean, we could just still count it, you know, and then just include the 3 in both the head and the tail. You know, I think that might be less complicated. So in that case, so halfway, and we've established that capturing the 3 would be the floor. Be the floor of this, which I don't think is a thing here. But we can make it a thing, so that's okay. And floor is just the integer, the lowest integer, or the lower integer, the largest integer in this case. That makes sense, yeah. So halfway, so this will be the value of that 3. So then the head and tail, and really this is just, we could have, yeah, we could just recycle this, right? Let me think about that. So then the head will be that, the number from the beginning to halfway minus 1, or just halfway. Let's just do this out, because I actually don't know if this is the right, or if this makes sense. So let's see. So halfway in this case would be 0, 1, 2. So it'd be 2. So if we go from the beginning to 1, we will get these 2. If we go from 2 to the end, that will include the 3. So I guess we could just cut the 3 out by adding 1. Does that make sense? Because then we're avoiding a situation where it's including the 3. Or we could just leave the 3 in there. Or excuse me, yeah, which is what this does. So we're going from 0 to 2. And then we're ending with 0 to 2, but backwards. Yeah, that works. That works. It does change this a bit, but that's okay. And then we check if they're equal. And then we return the result. Okay, cool. That makes sense to me. So let's try it out. Or what we could try out first is the palindrome. Let's just make sure that works, right? Is palindrome. Let's say, I don't know. Kayak. So that's an odd number. So let's try that. False. And that's not true. Okay. So let's help ourselves out here. Head is head, and tail is tail. Oops. Okay. And then we'll do the same thing here. Even and odd. Blah, blah, blah. Okay. Cool. So it did not include the y here. So we wanted to add one. Also did not flip it. Oh, geez. Does that not work? Oh. No, I'm just trying things. Let's see. Okay. Man, I don't understand that. Zero, one. 0, 1. So it's halfway. Halfway is 1. I don't understand that. Why does it say halfway is 1? Head is ka, tail is ak. Let me see. Let's think. So, kayak. Blah, 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 blah. So I guess this is what we want, but does that make sense? Oops. Huh. I guess that does work. Look at that. That looks right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Blah, 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 blah. All right. I guess that makes sense. It's weird. Okay. So then, yeah, actually, I'm confused. What is this? Now I want to know. Print len num divided by 2. Len num and then print halfway. Because I'm curious what this does. Okay. Cool. Blah blah blah. Okay. So it says halfway is 9. That makes sense. Okay, good. That's doing what I expected to. Okay. Good. All right. So this makes sense, but now we wanted to turn around. I thought this was the way. Let's just Google it, because how to turn a string around with indexing. Begins at the character before halfway. So all the way to the beginning, moves left. Oh. Oh, that's so funny. It is doing what it's meant to do. But we don't want to start at the halfway point. We want to start at the end. That's funny. Oh my god, that's silly. Yeah, okay. Oh my gosh. I could have gotten that with time, maybe, I don't know. That's funny. Okay. So does this make sense? No, it doesn't. So we also have to change that as well. Okay. Okay, cool. All right, cool. This makes sense. Oh, and then we got to stop halfway. Oh, jeez. There we go. Nice. Yeah, we do have to stop halfway, folks. Okay. Sweet. Let me see. Oh wait, I do have to read this error message. Blah 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 blah. Slice indices must be integers or none, or have sliced indices. Integers or... Are you saying this is not an integer? I'm confused. So... Oh, I forgot. Yeah, dividing. Gotta remember that dividing does make things a float. So why didn't that... I guess the floor kind of shielded me from that. Gotcha. Let's mess it up here. Gotcha. Sweet. All right. So now the big event. Oh gosh. Int object is not iterable. Oh, lol. Okay, I know what you want. Where are you? Range. Boom. Oops. Not supported between int and string. Highest. Oh, right, because highest is a digit. So I guess we can just say int here because we don't want to mess with the string. 9409. Okay. Well, that's not good. So first of all, that's not even a palindrome. So that tells me that this did a false positive. All right, let's see what happened. So with this is an even value. We looks like huh. I'm not sure. So let's do it this way then. Okay. Gonna run it again. Okay. All right, I see. We're running into that issue. So it's even. We don't want it to exclude the halfway value. So we'll do that. But we will do that. No, that didn't make sense. So it's halfway minus 1? I have to think about this now. So we start at the end, and we go to where halfway is. So it's it wouldn't be halfway minus 1. That doesn't make sense. Why is it halfway minus 1? 0, 1, 2. Oh, that's why. 0, 1. Okay, so halfway is 2. So it goes to halfway. Halfway is 2, so it's from 0, 1, 2. Something happened there. Halfway is the length of num, which is 4, divided by 2, which is 2. Halfway is 2. So then we take the head and start at the beginning and end at 2. 0, 1, 2. That should have... What? But it only ends at halfway. 0, 1. This is weird. This is very weird. All right. So now I'm curious, like, will this work? I honestly don't understand. Like, dead ass. I really what? Am I mistaken? Like, I must be mistaken. Like, so this returns, okay, it says it returns it in, but that's okay, that's fine. Okay. It's not even that one, but all right, let me I need to test my sanity here. I need to test my sanity here. Excuse me. Okay. A little detour, just because I don't remember. Let's do it to 3. Why is that happening? 0, 1, 2. 1, 2, 3? Has the indexing changed? That's crazy. What? I am so confused. Why is this happening? Did Python update the indexing? I'm so confused. Wait, what? Oh, is it the range? Are you telling me that the range is different than the indexing? Yeah. Okay. Oh wow, that's tricky. Okay. That makes more sense. I understand now. All right. This should work. This should work. Yeah. Great. So then 3 is that. Oh god, I should have deleted the printing. It's that. Let's just comment it out right now. Cool. That's fun. Wow. What a funny lesson, huh? That's good though. That's fun. All right, cool. We learned some stuff, you know? Okay. It's 9:35. Am I doing another one? I will probably look at this now. 2520 is the smallest number that can be divided by the numbers from 1 to 10 without any remainder. Yeah, we'll do this later. I want to switch it up. But yeah, thank you for watching. This was educational. See ya.